Hello, and welcome to my mid-project presentation for Comp 631. My project is distributed hash table-based authentication. My name is Chris Dean, and I'm going to start off with a brief recap of what my project is. So the idea of my project is to use the architecture of a distributed hash table to provide a user authentication service. The idea is we use a user's username as a key, and we store some sort of cryptographic verifier of a user's identity, and then we leverage we define a custom lookup, which is a cryptographic protocol, which looks up a user and then returns some sort of proof that the user and the password match. So obviously we have to provide a user and some sort of cryptographic derivative of the password, and then we return the proof that a user and the username matched. So that way, we're not just returning whatever value happens to be there. So the initial timeline for this project was spend weeks 0 and 1 on exploration, looking at libraries, figuring out exactly what we need, looking at authentication protocols. Weeks 2 and 4, 2 to 4, on our distributed hash table our distributed hash table implementation. Weeks 5 to 7 on our authentication. Weeks 8 and 9 on integrating our authentication with our distributed hash table. And then weeks 10 to 11, testing and evaluation of the system. And we will talk a little bit about where that has gone correct and where that has fallen down so far. For the project, I'm going to talk about what items have been completed for it. First, we have identified an acceptable distributed hash table library. That library is an implementation of Kademlia, which is kind of a if you look at the Wikipedia page for it, it is a modern third generation distributed hash table. The biggest things that are interesting about this, it does have the login, where n is the number of nodes, lookup time, so you don't have to flood the entire hash table to find a value. We have had to modify this library to support auxiliary information when doing a lookup, and that auxiliary information has to do with a cryptographic derivative of the password that you're sending over. So you're sending over both the username and a cryptographic derivative of the password. You wouldn't want to just send over the password for obvious reasons. There's big security implications about putting a password on things. But we had to modify the original Kademlia library to support this extra information that it didn't initially support. I built a small cluster for testing, and I can show you that in a second. It's a Raspberry Pi based cluster that it's a Raspberry Pi cluster with 5 nodes. Here it is. It's a little big right now. There it is. And you can see it's got 5 nodes. Currently only 4 of them are working. But it's got 5 nodes and a switch, and they are all running the latest version of Raspbian to do this. And I've used this cluster for running testing and getting some amount of benchmarks on exactly how well my implementation is doing, and using it for debugging purposes to see if I have any issues. I have put together a benchmarking program, which is super important to know how well things are, to see if changing code increases or decreases the amount of operations we can do, and have implemented a custom data storage thing. This is a very important part of the project, because you can't just store everything in memory. So I have implemented a database solution, which allows me to store basically user identifiable or user information such as the username and the derivative of the password in it stores in a database. Currently, I'm using SQLite, but with the library I'm using, which is SQL Alchemy, it should be very easy to switch over for other if someone wanted a different database. And I have this is also important for with the custom data storage. When you look up a value, you for the opaque protocol, you would need to combine it with obviously the auxiliary data you were putting out, and you're not returning the pure value stored, but just the proof that the username did or did not match the password. I have also begun implementing the opaque protocol, which was supposed to be done by now, but we're going to talk about some of the technical issues that I've run into that have put me a little bit behind schedule, but I'm hoping to catch up in these next 2 weeks. So the technical issues, the first and definitely the biggest technical issue that I've been running into is the first library that I looked at, which was OpenDHT. It did not support this auxiliary information during the lookup. And I looked at what would be the viability of modifying the library to support it. And it was all, it was it's a very large library compared to the one that I'm currently using. And it was all written using Python bindings into a C++ framework, which was, it was just one of those things where it was kind of prohibitive on going through and modifying code in lots of places to usher this information through. So I ended up pivoting and having to switch libraries, which set me back probably a week or two in the implementation. The other issue I've been having, which has been definitely not as big, but just a little annoyance, is issues with the node stability in the cluster. The cluster, it often is pulling too much juice from the wall, too much electricity from the wall, and a node might go down, or we might have a network issue, such as like a wire coming loose because someone walked near the cluster, that really just kind of has invalidated some of the testing that I have done. Those are the two big things. So I would say I'm with the next 2 weeks being dedicated to integration. A little bit of that will be more on the side of finishing up the opaque implementation, but that should be doable in the next 2 weeks to integrate that into the system. Last thing I'm going to talk about is the testing results that I have seen so far. And so you can see actually currently in the background, you can see I'm running an extended test on the cluster. But here you can see some of the preliminary results we've gotten. So this top line here is the number of operations that we're getting per second on the cluster. So the number of operations, it's sitting between 80 and 100 per second. I was expecting this to be a little higher, but honestly, it's kind of one of those numbers in computing that it's hard to exactly quantify exactly if it's good or bad. But it's also a number that would go up if I were using more powerful computing or a faster network or a there's just a number of factors that you could increase this number by just throwing more money at the problem. But you can see it was roughly increasing with the node just a little bit, but for some reason on the fourth node, number of operations per second went down. I'm not 100% sure if this is because of the way I was setting up the nodes. I was connecting them all to one central node, and I'm not sure if that's the best way to connect them or to try to put it out into more of a tree-like structure. The other line here is the number of, it's up here, it's called the number of misses per second. That's maybe probably not the best way to describe it. It's the number of lookups that failed per second. So here you can see initially we had about with just a single node, we had a lot of failed lookups, and I'm not 100% sure why we had so many failed lookups with just a single node. May have had to do with lookups timing out or whatnot. As you can see, the more nodes we've had, the fewer failed lookups we've had. So I'm not 100% sure if this is values not getting to the database before they're being looked up again. It's sometimes pretty hard to know exactly what the issue is with this system, but that is definitely something I will be looking into to see if this is a problem with the implementation or if this is a fundamental constraint, a fundamental property of the distributed hash table system, that there may be some lookups that fail, which would be definitely like detrimental to a user trying to log into a system that used this authentication service. So that's my mid-project presentation. Thanks for listening, and I think that's it.